afternoon, Tigers. We are going to be working with equations today. We are going to be changing equations that are in standard form to slope-intercept and slope-intercept back to standard form. Also, I can construct a linear function in standard form from a description of a relationship. We'll come back to that in just a little bit, but for now, we're just going to remind ourselves of what the form of the equation looks like when it's in standard form. Standard form is when an equation reads ax plus by is equal to c, meaning ultimately x plus y is equal to c, or the constant. On a side note, if you have changed the equation from slope-intercept to standard and your a term is negative or greater than 0, as it reads here in this text, then we are going to multiply by -1, or you can divide both sides by -1 to make sure that the a is in fact greater than 0. I'll show you how to do that. We'll have an example of that in just a little bit. And then this ever so familiar equation, I know you know it very well, y is equal to mx plus b, or slope-intercept. And if an equation is slope-intercept form, then we have to know how to change it back to standard form. Both equations are used for different reasons, and you'll learn more about that later. Change from standard form to slope-intercept form. So as you can see, we talked about the original equation in standard form would be ax plus by is equal to c, or the constant. As you can see, it's in the format standard form, and so we are going to change it into slope-intercept form. We know that any equation that's in slope-intercept form is going to be equal to y. So the idea here is to isolate y, or get it by itself. In order to do that, then I'm going to subtract 2x on both sides of the equation. So all that's left on the left is y. And I know when it's in the format y is equal to mx plus b, then my x term is up front. So I'm just going to go ahead and write -2x, and then remember that this is a -7, which would be my y-intercept. The second example, 5x minus 2y plus 2. It's not exactly in standard form, but it almost is. It's just that our 2 is on the left side, which eventually will be our constant. On the right side, we know that it becomes its opposite. So really on this problem, I can do 2 steps in one. I can get rid of the 5x, because here's what I'm trying to get by itself, y. So in order to do that, I'm going to subtract 5x on the left, and also I'm kind of out of space, as you can see. You can make it work. And then this +2 can also be moved to the other side of the equation. If you're more comfortable, you can do that in 2 steps, but really we know that eventually I want -2y to be by itself. So I have -2y, and then on the right I'm going to have -5x minus 2. Now to get y by itself, I need to divide through by a -2, because we know that this means -2 times y. The opposite of multiplication is division, and we always divide by the coefficient. The coefficient in this case is -2. So that's easy on the left. We know that all that's left is going to be our y term. And then on the right, we have to remember that we're dividing both terms by -2. So a negative divided by a negative is going to give me a positive. So I'm just going to say 5/2 x. And then I've got a -2 divided by a -2. That's going to give me a +1. As far as the m term being an improper fraction, that is perfectly okay. In fact, I would prefer that you leave it as 5/2 x plus 1. So what do we do in this problem? We got y by itself. This is kind of like when you guys were working with solving for a particular variable. So as you're doing these problems, I want you just to think, I'm always solving for y. How do I get y by itself? So we subtracted 5x, we subtracted 2 on the right, and then we're not solving for -2y, we're solving for y. So that's why we divided both sides by -2. Remember that a negative divided by a negative here is always a positive, and you can just leave that as an improper fraction. On example number 3, once again, we are solving for y. We want to put it in slope-intercept form. That's otherwise known as y equals, oopsie, I like the highlighter. We'll just leave it that way. Y is equal to mx plus b. Okay, making sure I have ink. So to get 3y by itself, I'm going to have to add 3x to both sides of the equation. So that makes it go away. All that's left on the left is 3y is equal to, I'm going to go ahead and move my 3x up front because I know that that's my equation, y is equal to mx plus b. Now I want to divide through by the coefficient of 3. When I do that, all that's left on the left is y. 3 divided by 3 gives me 1. I'm just going to write x. I don't need to write 1x. And then 6 divided by 3 is 2. So make sure that you have simplified. One more example, moving from standard form to slope-intercept form, we're going to get, in this case, it's a 2y. We're going to get that by itself. So I notice I have a -7x. I want to add 7x to both sides of the equation. Another way to think of that is when -7x travels over the equal sign, it becomes its opposite. We end up with 2y is equal to 7x. Again, moving my x up front and my y-intercept to the right, because we know that this is my mx term or my m, and this is going to be my b. Now I want to divide through by 2. And this is a really good example of when to leave a value in improper fraction form and then when to turn it into a mixed number. And here's my advice. When we're talking about m can be improper. When I'm graphing, which is what we're moving towards, when I'm graphing, I would rather go up 7 and over 2 than up 3.5 and over 1. So slope, leave is improper. However, if I'm graphing the y-intercept, then we're talking about either graphing 7/2 on the y-intercept or 3.5. So of course you'd rather find 3.5 than count up 7/2. So you should change that into a mixed number. Oh, there is one more on this, and all I would say on this problem is just flip-flop these since I know that I'm solving for y, and we'll just divide through by 3. So your final answer, y is equal to 4/3 x. Easiest way to get